Blockchain Fundamentals. Module 1. Introduction to Blockchain Technology. What is blockchain? Blockchain is a distributed database made up of a growing chain of blocks. It is often labeled as a digital double bookkeeping. Each block contains data and is cryptographically linked to the previous block, so that once inserted into the blockchain, a block cannot be withdrawn or replaced. Possible analogies for blockchain is an accounting book in digital format, with page, block, containing multiple records. It is almost impossible to change any previous page, block, without leaving a trace. Blockchain can be described as a database that is replicated across multiple nodes, with each node maintains a replica. Decentralized scheme makes the system more resilient to tamper attempts. Brief history and evolution of blockchain. In 1991, there is the first description of a cryptographically secure blockchain. In 2008, the mysterious Satoshi Nakamoto publishes Bitcoin description. In 2009, the cryptocurrency Bitcoin blockchain is launched. In 2015, the Ethereum network is created, introducing smart contracts. Right now, we see enterprise and institutional adoption of the blockchain technology. As seen in the table, we can say that we are currently in the fourth iteration of the blockchain technology, with the association of artificial intelligence with blockchain. DLT versus blockchain. Distributed ledger technology. Distributed ledger technology is the generic term for technologies that use a network of nodes to maintain a distributed ledger. Data is stored in multiple locations to ensure decentralization and security. Blockchain is a specific type of DLT, with data organized into blocks, chained chronologically through hashes. Why distributed? Centralized systems. Centralized systems have single control, and thus a single point of failure. They are dependent on an authority. Distributed systems. As the name implies, distributed systems have distributed control, provide redundancy and fault tolerance. Blockchain fundamental properties. We can say that the main properties of blockchains are decentralization, transparency, autonomy, immutability, and anonymity. Fundamental concepts. Cryptography. Cryptography is of great importance for blockchain. Main cryptography technologies for blockchain includes public and private keys, digital signatures, and data encryption. These technologies provide transaction security, identity verification, and data protection. Fundamental concepts. Hashing. Hashing is a mathematical function which is unidirectional, used to generate unique fingerprint. The main characteristics of an hash function is to be deterministic, crash-resistant, and quick to compute. Fundamental concepts. Consensus. Why consensus? The nodes of the network need to agree on which blocks are added to the blockchain. This is achieved through consensus mechanisms such as proof of work, proof of stake, and others. Proof of work, POW. Proof of work is Bitcoin's consensus mechanism, being based on a computational challenge that involves the SHA-2 5-6 hashing function and brute force computation. It consumes massive energy consumption. Each participant, miner, tries to build block transactions whose SHA-256 obeys the difficulty of the Bitcoin network brute force computation. Proof of stake, POS. Proof of stake is another consensus mechanism. It is based on economic participation, with the so-called validators having an economic interest in the blockchain network. If fraud occurs, validators will be negatively affected.